We want to check and see if Rolle's theorem will apply to the function x squared plus x minus 6 divided by x minus 1 on the interval -3 to 2. And if it does, we're asked to find all values of c that are guaranteed by Rolle's theorem. So we need to check and make sure that this function is continuous on the closed interval -3 to 2, that it is differentiable on the open interval -3 to 2, and that when we plug -3 into the function, we get the same value as if we plugged in -2. So let's take a look at those three things. If we look at this function, we can tell that when x is 1, we're going to end up dividing by 0. The top is going to be -4, the bottom is going to be 0. -4 divided by 0 is undefined. That is going to give us a vertical asymptote and a point of discontinuity. So, is 1 in our interval? Well, unfortunately it is. So our function here is not continuous on the interval from -3 to 2. Now if our interval had been something like -3 to 0, or if it had been something like 2 to 10, an interval that didn't include 1, then we'd be okay. We'd be continuous on that interval. But in this case we have that asymptote right in the middle. Now, since we have that vertical asymptote, we know that we're also not going to have a derivative at that point. So kind of by definition, we are not going to be differentiable on the interval either. In this case, on the open interval. So we're not differentiable on -3 to 2. Now, as soon as we weren't continuous, we knew that we couldn't apply Rolle's theorem, but we should still check all of these things and see what's going on. So let's check the last one. Let's consider f of -3. And I'm going to use my trusty calculator to give me a hand with that. So I'm going to have -3 squared plus -3 minus 6 in the top. And I'm going to put my entire numerator in parentheses so I can do all this in one step. Then I'll divide by my denominator, -3 minus 1, also in parentheses. I'm using parentheses because I want the calculator to find one number for the numerator and one number for the denominator before it does the division as represented by that fraction bar. And it turns out if I do that, I get exactly 0. And if I do the same thing with a 2, let's see what we get. Again, being careful about my parentheses. I also get 0. So we were okay on the third requirement. The function's not continuous and is not differentiable, but we did have the two endpoints at the same height. All it takes is one of the three things to fail, and we can't apply Rolle's theorem. In this case, 2 of them failed, so we definitely can't apply it. But not a bad idea to check all 3, and your web assigns will expect you to do that as well.